Today we are going to be treating friction. And what is friction? Friction is the force that opposes the relative motion between two objects in contact. As we have on the board, objects on a horizontal plane. This is a typical diagram of an object on a horizontal plane. We have the weight acting vertically downward, the normal reaction acting vertically upward. We have the applied force. This applied force here can either be a pulling force or a pushing force. When you push, you are applying a force. When you pull, you are also applying a force. And then when you apply a force to something, the force that acts opposite to the direction of the motion is called the friction. So here we have normal reaction is equal to weight, which is equal to mass and gravity. The formula for weight is mass and gravity. But how do we get normal reaction being equal to weight? The reason is that both normal reaction and weight here are parallel to each other. Normal reaction act vertically upward, while weight act vertically downward, and they are parallel to each other. Alright, let F equals to friction, N equals to normal reaction, P is equals to pulling or pushing force, W is equals to weight, R is equals to resultant force, mu equals to coefficient of friction. And what is the value of the formula for our coefficient of friction? Mu is equals to friction over normal reaction, or friction over weight, because normal reaction is equal to weight. Or we say friction over mass times gravity, the formula for weight, mg. Now resultant force. Why is resultant force important here? When we have two or more forces acting on a particular object, there is always a resultant force. And what is a resultant force? Resultant force is the net force acting on a particular object. A. Two forces acting on an object in the same direction. How do we get the resultant force? We get the resultant force by adding the two forces together, since they are both acting in the same direction on a particular object, on the same object. B. Two forces acting in opposite direction on the same object. So what's the value of, or what's the formula for the resultant force? The formula is going to be R is equals to A minus B, provided that A is greater than B. Here R is equals to B minus A, provided that B is greater than A. Now, let's go back to how resultant force is related to friction, or how resultant force is related to this diagram. Resultant force, applied force, which is the pulling or pushing, minus the resultant force equals to the applied force minus the friction. If the object moves in the direction of the applied force, do you get that? When this force is applied, should this object moves in the direction of this applied force, that shows this applied force is greater than the friction or the force opposing it. So the resultant force between this applied force and the friction is equal to applied force minus friction, because the applied force is greater than the friction for it to move in the direction of the applied force. The second resultant force says R is equal to F minus P, friction minus applied force. Should the applied force cannot move the object? Yes. If the applied force cannot move the object, it could be because the friction is greater than the applied force. So for us to get the resultant force between the two forces, we are going to take out the applied force from the frictional force, subtracting the applied force from the friction. That's how we get the value of the resultant force. The third one here says applied force is equal to frictional force. Here what they are telling us is that the resultant force is equal to 0. And why is it like that? If the object is at rest. If the object is at rest. Let's go back to this formula. This formula here says resultant force is equal to mass times acceleration. An object at rest has zero acceleration. So when the acceleration is zero, mass times acceleration is going to give us zero. So definitely our resultant force is going to be zero. That's the same thing applied in this place. That is, resultant force is equals to